First thing you notice here, guys, is that I have two equations that we're going to be using throughout this handout. So at the top of your paper, I need you to write down for me these two equations, which are distance is equal to rate times time. Write this at the top of your paper. We're going to need it in a minute. And work is equal to rate times time. We're going to need these here in a second. Any of those equations look familiar to you guys? You seen those before? Kind of, sort of. All right, we're going to be using them to answer the 4 questions that we're going to be going over. Okay? So I'll be referring to these here in a second. So just make sure you have them written down at the top of your paper. All right, here we go. Let's get started. First one, it says that most tunnels are drilled using tunnel boring machines that begin at both ends of the tunnel. Suppose that a new underwater tunnel is being built and one tunnel boring machine alone can finish the tunnel in 4 years. A different type of machine can tunnel in the other side in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? So the idea here is we're building a tunnel. We got one machine at one end, another machine at the opposite end. And we're going to be digging until we reach into the middle of it. So it says here that one of them, if they did that alone, it would take them 4 years to dig this tunnel. The other machine's a little faster. They can do it in 3 years if they were working alone. But that's not the case. They're going to be working together. So how long would it take if these guys are working together to finish up this tunnel? All right, so here we go. The first thing I'm going to do is I'm going to let X represent the time that these two machines are working together. X is going to represent how much time it takes for these two machines working together to finish this tunnel. Now, when I say time, let's be more specific. Is time in hours, minutes, days, months, years? What does it say? Years. Okay, so after this, I'm going to put that I am talking in years. All right, so this is what we're going to be looking for. We're going to look for how long would it take for both of these machines to dig this tunnel working together. Now, on the front, I asked you guys to write two equations. One of those equations was work is equal to rate times time. This is one of the equations I had you write down. Now, let's think about this. If work is equal to rate times time, what would time be equal to? In other words, how do I solve for t? I wanted to solve for t. I want t by itself. What would I do?
R divided by W.
Okay, close. We're going to take this r right here and we're going to divide it. Whenever they're multiplying, we do the opposite. We divide. So time is equal to the work divided by the rate, which is what we're going to be using here in a second. We're actually going to use the equation t equals W divided by R, where t represents time, the W represents the amount of work, and R represents the rate, or how fast we're going. All right, so here we go. I'll go ahead and use the same one here. We're working together. So we got the time it takes for machine 1 to dig this tunnel. We're going to add to that the time it takes for machine 2 to dig this tunnel. Now, if I add those together, what it's going to give me is the time it takes working together. All right, so if I take the time it takes for machine 1 to do it, add it to the time it takes machine 2 to do it, I should get the time it takes working together. Now again, I just told you that time is equal to work divided by rate. So let's talk about machine 1. The work they're doing. What's the work they're doing? They're digging 1 ton. So the top number is 1. That's the amount of work they're doing. 1 ton. Rate. How fast can that first machine dig this tunnel? They told us 4 years. Okay, so the 4 goes underneath it. That's the rate. That's how fast they can dig the tunnel. Plus, now let's take a look at machine 2. Remember, time is equal to work divided by rate. And the work they're doing is digging 1 ton. How fast can that second machine dig the tunnel by itself? 3 years. Right over there it says it can dig it in 3 years. We're going to set that equal to the time it takes working together. So again, we're still digging this 1 tunnel. That's the work, 1 tunnel, over the rate. Now the problem here is we don't know what that rate is. As a matter of fact, we're calling it X. So X is representing how much time it works, how much time it takes to dig this tunnel working together. All right, so this is our equation. What we need to do is we need to solve for X. These are the type of equations that we've been working over there on the lab and in class. This is called a rational equation. To solve this, what I need to do is I need to multiply both sides of my equation by the least common denominator. So the question is, what is the least common denominator? I've got a 4 as a denominator, I've got 3 as a denominator, and I also have an X as my denominator. So what would be the least common denominator?
X.
Well, it's part of it, but it's not only X.
3x.
Nope.
What was 3x?
No. Now we're just throwing stuff out there.
No.
I'm asking for the least common denominator. All right, everybody write this down on your paper because we can't find the least common denominator. So we're going to take all the denominators, which are the 4, the 3, and the X. Those are the 3 denominators. And we're going to find all of their prime factors. So 4. What are the prime factors of 4? 2 times 2. 2 times 2 is 4. What about the prime factors of 3? 3 times
1.
1. What about X? Just X. So these are the prime factors of each of our denominators. Then what we're going to do is we're going to look for see if we have any common factors within these denominators. And in this particular case, there are. So what I'm going to need to do for my least common denominator is use every single one of these factors. I need to multiply all of this stuff together. In other words, I'm going to multiply 2 times 2 times 3 times 1 times X. Whatever that is my least common denominator. So what do you get when you multiply all that together? 12x. 12x is my least common denominator. That's what I need to multiply both sides of my equation by. All right, so let's go ahead and do that. Let's multiply both sides by the least common denominator. So here we go. This first fraction here, 1/4. Notice how that 4 right there is going to go into that 12. How many times does 4 go into the 12? 3 times. So now what I have is a 3x. And when I multiply this 3x times a 1, I'm going to end up with a 3x. What we're doing is we're multiplying 12x times 1/4, which is how we're getting this 3x here. Let's do that again. 1/3, that's our next fraction. Notice how 3 will also go into 12. How many times does 3 will go into that 12 right there? 4 times. So now I have a 4x. And when I multiply that 4x times this 1 over here, I'm going to end up with a 4x. So right now I have 3x plus 4x. Now let me go to the other side. Notice this time the x's are going to cancel each other out. This x and this x would cancel each other out. So what I need to do is multiply 1 times 12. And 1 times 12 is 12. So my new equation is 3x plus 4x is equal to 12. Now that's a lot easier to work now that it doesn't have any fractions in it. All right, so let's see what we get here. First, I'm going to combine the like terms. We're going to add 3x and 4x, which is going to give us 7x. Bless you. 3x plus 4x is 7x. Remember, we're solving for x here. So what do I need to do next? Divide by 7. So what is 12 divided by 7? Put that in your calculator.
1.714.
1.714. We'll go ahead and round it to the nearest 10. So we'll say 1.7. So what did I just find? What does that 1.7 represent? Time. More specifically, time in years. So what we're saying here is that if both of these machines are going at the same time, it should only take about a year, actually a little over a year and a half, 1.7. That would be just a little over a year and a half. Okay. So they can get it done a lot faster if we got both machines working at the same time. That's what that's. All right, so there's the first one, 1.7 years. Let's take a look at another one here. Number 2. Number 2 says that we have a car traveling 300 kilometers in the same time that it takes a freight train to travel 200 kilometers. The speed of the car is 20 kilometers per hour more than the speed of the train. They're asking us to find the speed of the car and to find the speed of the train. So we're looking for 2 things this time. We're looking for the speed of the car, and we're also looking for the speed of the train. So here we go. I'm going to let X represent the speed of the train. X is going to represent the speed of the train.
Can you just pick anything to represent?
Yep, I can use A, B, C, I can use any letter in the alphabet.
No, I mean, like X, does it have to be speed of the train? Yeah? Okay.
Yeah. Now the next one here, remember they're also asking me for the speed of the car. I also want to know what the speed of the car is. Now if you read closely here, look what it says about the speed of the car. It says the speed of the car is 20 kilometers more than the speed of the train. So if I'm calling the speed of the train X, what do I need to call the speed of the car? No. What? Now we're getting closer. What? 20 plus X, or X plus 20. In other words, however fast the train is going, I need to add 20 more to that, because it's going 20 kilometers more than the speed of the train. So I need to add 20 to the speed of the train, which means I end up with the equation, or not the equation, but X plus 20. All right, so X is going to represent the speed of the train, and X plus 20 is going to represent the speed of the car. Now we got to come up with an equation. Again, I gave you 2 equations at the beginning of class. I gave you one that said distance is equal to rate times time. Distance is equal to rate times time. Well, if distance is equal to rate times time, then time should be equal to distance divided by rate. In other words, if I solve for t, I would divide both sides by r, which would leave me with t overall. So this is what we're going to be using here in a second. We'll be using that in a second. All right, so let me go back over here. Notice the first sentence. The first sentence says that a car travels 300 kilometers in the same time. That's the key part here. In the same time that a freight train travels 200 kilometers. So they're traveling at the same time. So we got the time of the train is going to be equal to the time of the car. 2 times are equal to each other. That's what this says right here. Times are the same. Now I also told you that time is equal to distance divided by rate. So we're going to use that. Let's start with the train over here. The time of the train. What's the distance that the train traveled? Look at the 200. 200. So this is how far the train traveled. 200 kilometers. What about the rate of that train? How fast is that train going? X. Says right here, guys, the speed of the train is X. So that's what we're going to use right here. The speed of the train is X. All right, now let's look at the car. The time of the car. Well, remember, time is equal to distance divided by rate. What was the distance that the car traveled? 300. There it is right there, 300. That's the distance. The rate, or the speed of the car. What are we using for the speed of the car? X plus 20. X plus 20. All right, so here's the equation that I'm working with. What I need to do is I need to solve for x. When I solve for x, that should give me the speed of the train. So the question is, how do I solve this one? Notice it's a little bit different from the first one we did. Actually, this one's a little easier. What did we do when we were over in the lab? How do we do these type of problems? Cross multiply. So that's what we're going to do here. We're going to cross multiply. So what I'm going to do is multiply these two numbers here. X times 300 should give me a 300x. If I multiply these two things together right here, 200 times x plus 20. What do you get when you multiply 200 times x plus 20? Well, 200 times x would give you 200x, and 200 times the 20 would give you a 4,000. So now what we have is the equation 300x equals 200x plus 4,000. Remember, I'm trying to solve for x, so the next thing I'm going to do is get all the x's on the same side. And I'm going to do that by subtracting 200x's. So 300x minus 200x would be 100x. Over here, all I have is the 4,000. All right, now what? Divide. We're going to divide by 100. So 4,000 divided by 100 would be 40. So x is equal to 40. Now what the heck is x? What is x represented? It's the speed of the train. Therefore, I know the speed of the train is 40. 40 what? There it is. It's that kilometers that we were talking about earlier. Now, since I know the speed of the train, I should be able to find out the speed of the car. Remember, the speed of the car is 20 more than the speed of the train. So what would that make the car speed? 60. The speed of the car is 60 kilometers per hour. All right, so we just answered the question. We just found the speed of the car, and we also found the speed of the train, 40 and 60. All right, any questions on that? It's a little tricky getting them set up, but once we have them set up, it shouldn't be too bad from there. All right, number 3 on the other side. Number 3, it says that one electronic reader can read a deck of punch cards in half the time another reader. Together they can read the deck in 8 minutes. We want to know how long would it take each of the readers alone to read the deck of punch cards. So how long would it take each of the readers to read this deck of cards? All right, so here we go. This is number 3. First thing I'm going to do is I'm going to let x, there's 2 things I'm looking for here. I'm going to let x represent the time it takes for the first reader to read this deck of cards. Now, when I say time, what am I talking about when I say time? Minutes, hours, seconds, days, minutes. So out to the side, I'm going to make sure that I put down that I am talking about minutes. So again, x is going to represent how long it takes for the first reader to read this deck of cards by itself. But we got a second reader. So I also want to find the time it takes for the second reader to read this deck of cards by itself. The question is, what am I going to use to represent that? What's that? X divided by 2. Now that is possible. However, when I say, let's see, where is it? One electronic reader can read a deck of punch cards in half the time another. Well, if we're saying half of the other, wouldn't that be the same thing as twice the other? Couldn't I also do 2x, wouldn't this one right here be half this amount? So it'd still be the same thing, right? And it's just easier to work with 2x than it would be to work with x over 2. So that's why I'm using 2x. Just remember this one right here is still half as much as this one right here. So I'm still within my parameters. All right, so let's see here. Let's see if we can set up an equation. Again, remember earlier I said that work was equal to rate times time, which we also said that time was equal to work divided by rate. So we're going to be using this little thing here again in a second. Time is equal to work divided by rate. All right, so remember, these readers are working together. So what I'm going to do is I'm going to take the time of reader 1 plus the time of reader 2. When you add those together, you get the time of both of these working together. All right, so this is what we're going to use to set up our equation. Now again, remember time is work divided by rate. So I'm looking at the first reader right now. The first reader, the work they're doing is that 1 deck of cards. They're reading that 1 deck of cards. The rate, or the speed, of that first reader. What's the rate of that first reader? What's that? X. It's right here. Let's go to the second reader. They're still reading that 1 deck of cards. What's the rate or the speed they're reading it at? It is, again, right here, it's 2x. And the time working together, well, again, they're still reading that 1 deck of cards. Now, they told us how long it would take for both of them working together. What did it say earlier? 8 minutes. So that's what we're going to use for our rate over here. 8 minutes. So here's the equation. Now we've got an equation to work with. In order to solve this equation, just like I did on that first one, we're going to need to multiply both sides by the least common denominator. The least common denominator. So, because we're still having trouble finding the least common denominator, I'm going to come out to the side. I'm going to take all of my denominators, x, 2x, and 8, and I'm going to factor them out. Of course, x is just x. 2x is just 2 times x. What about 8? What are the prime factors of 8? 2 times 2 times 2. All right, so here I've got all my denominators factored out. Now I'm going to look for some common factors. Right here I see some common factors. So that's going to be part of my least common denominator. This right here, they also have in common. But these two over here I haven't used, so I've got to use those as well. 2 times 2 times the x.
So why you can't triple the last two.
Well, right, because they're in the same. It's got to be same factors in the other denominators. All right, so what do I get when I multiply all of this together? 2 times 2 times 2 times x would give me a 8x. So that's what we're going to use for our least common denominator, 8x. So here we go, 8x. So now let's start multiplying here. Notice how the x's here are going to cancel each other out. So really what I'm going to do is multiply 8 times 1. And 8 times 1 would give me a 8. Now I'm going to move on to the next one. I've got 1 over 2x. Notice how the x's are going to cancel each other out. But also notice that this 2 right here will go into 8. How many times will that 2 go into that 8? 4 times. So what do you get when you multiply 4 times 1? 4 times 1 is 4. Going to the other side. Notice this time what's going to happen is that this 8 and this 8 are going to cancel each other out. So I need to multiply 1 times x, and 1 times x is just a x. So the equation I'm working with here is 8 plus 4 is equal to x. I need to solve for x. Well, what do you get when you add 8 plus 4? 8 plus 4, guys. 12. So x is equal to 12. And what does 12 represent again? The first reader. So this first reader can do the deck of cards in 12 minutes. So if that first one can do it in 12 minutes, how fast is the other one going to do it in? 24 minutes. So one of them, they can do it in 12 minutes. The other one, they can do it in 24 minutes. Notice how it still meets that. Where is it? Here. Half the time. So 24, half of 24 is 12. That's that half the time. All right, so that's number 3. We got one more to look at here. Number 4. This one's the tricky one. Number 4, we got one pipe that can fill a tank in 6 hours, while another can empty the tank in 2 hours. If both pipes are open at once, how long will it take to empty out the full tank? So we got 2 things going on. We're putting water into a tank, but at the same time that we're putting water into that tank, we're also taking water out of the tank. So 2 things are going on at the same time. Why do we want it? Well, good question. Why do we want it? I don't know. So what we want to know is how long would it take to empty out this full tank? So here we go. We're going to let x represent the time. The time it would take to empty the full tank. X is going to represent how much time it takes to empty out the full tank. Now when I say time, what am I talking about? Hours. That's this I want to put that. I am talking in hours. All right, so again, we had that equation earlier. Work is equal to rate times time, which means that time is equal to work divided by rate. Which again, we'll be using this thing here in a second. All right, so like I said, this one's a little bit tricky here. Here's what I'm going to do. I'm going to take the time that it takes to empty the tank. Time that it takes to empty the tank. I'm going to subtract from that the time it takes to fill the tank. Because I want to take out what we're putting in. That's why we're subtracting. Whatever I'm putting in, I want to make sure I'm taking it out. That's going to equal the time to empty out this full tank. Totally empty. So it's going to give us the time it takes to totally empty out this tank. All right, so let's start with the first one, empty. Time. Time is work divided by rate. Well, the work we're doing here is emptying out this one tank. We got this one tank. The rates. They told us how fast it could empty out this tank. How long does it take to empty out the tank? There it is, 2 hours. That's the rate. We're going to subtract from that the time it takes to fill up the tank. So the work here is that one tank. The rate, what did it say about filling the tank here? Doing it in 6 hours. The total, the time to totally empty this out, well, the work here is still that one tank. How much time is it going to take? Well, that's what we're looking for, so we're calling that X. X is what we're looking for. How much time is it going to take to totally empty out this tank? All right, so there it is. Now I'm ready to start solving. And in order to solve it, I'm going to need to multiply by the least common denominator. I'm going to give you a second here, see if you can find me the least common denominator. Least common denominator. Here's the factors of 2, factors of 6, and of course the x. First thing you should notice is that they have some common factors here, and those common factors are the 2. Do you see any other common factors? No. But I can't just throw the other stuff away, so I'm going to include it also. There's the 1, there's the 3, there's the x. What do you get when you multiply all of that together? 6x. So 6x is what we should be using for our least common denominator. That's what I'm using. 6x. Alright, so 6x times the 1/2. Well, look at this 2 here. Notice how that 2 is going to go into 6. 2 goes into 6 how many times? 3. So what I'm going to do is take 3x and multiply it by 1. 3x times 1 is a 3x. Here's another way to look at it, guys. I've got 6 x's. What's half of 6 x's? Half of 6 x's is 3 x's. Go to the next one here. 1 over 6. Notice how this time the 6's are going to cancel each other out. So what I'm going to do here is multiply the x times the 1. And x times the 1 is just a x. Over on the other side, notice how we can cancel out those x's there. So if I multiply 1 times 6, 1 times 6 is 6. So here's the equation that I need to solve. 3x's minus 1x would give me a 2x. So now I've got 2x is equal to 6. If I divide by 2, 6 divided by 2 would give me a 3. So what did I just find? What is that 3? The time it takes to empty the full tank. 3 what? Hours. So it's going to take me 3 hours to completely empty this tank out. All right.